honorable dignitaries, our most valued speakers, and all the participants. A very pleasant good morning to one and all present here. Thank you for being with us today. It's my privilege to welcome you all on this occasion. I, Dr. Shalini Sachdeva, on behalf of National Institute of Technology, Delhi, would like to express my sincere gratitude to our chief guest, Jaswinder S. Ahuja ji, our guest of honor and the chairman of AICT, Professor Anil D. Sahasrabuddhe ji, and the advisor of ATAL Academy, Dr. Mamta Rani Agarwal ji. A warm welcome to the core team members, Deputy Director Amit Datta ji, Girdhar Garg ji, and IT staff members of ATAL. I would like to welcome all the coordinators, technical staff members, and participants for taking time and being a part of this program. AICT, in its endeavor to encourage academic excellence in technical education, has taken several quality initiatives, which also include enhanced impetus on the development of the faculty teaching in colleges across the country. The AICT Training and Learning Academy is one such initiative that has been conducting various activities for imparting, upgrading faculty's knowledge in thirst and emerging areas. Given the unprecedented COVID-19 backdrop, this year 1,500 activities in various emerging areas have been scheduled in online mode, and 63 such FTPs are commencing on 26 July 2021, that is today. These FTPs are being conducted by various prominent organizations such as IITs, IIMs, IIITs, NITs, IISc, ISI, JNU, BAC, DRDO, universities engaging distinguished experts from academia, industry, research organizations from within the country and abroad. So this was a brief intro. Now, with the due consent from our chief guest, Jaswinder S. Ahuja ji, I would like to request the IT team of ATAL for virtual lamp lightning and Saraswati Vandana. Sir, do we have your permission, sir?
Yes, please. Please go ahead.
Thank you so much, sir. Yes, please, IT team may please start. Thank you so much. Now, I would like to welcome Dr. Mamta Rani Agarwal ji, advisor of ATAL Academy and former additional secretary, Association of Indian Universities, former joint secretary, UGC, and director education, New Delhi. Mrs. Agarwal has been an international speaker at the University of Columbia, New York on urban education and in the Global Summit on Reforming School Systems in Global Cities, New York. She was the president of India's nominee on the Board of Governors of National Institute of Pharmaceutical Education and Research, Kolkata, member in other BOGs, and resource person on many academic subjects. She has edited 5 volumes reference book on National Education Policy 2020. With this, I would like to hand over to ma'am. Ma'am, please.
Thank you so much for such generous introduction. Good morning, a very, very good morning to all of you. Our distinguished chief guest of today's session, Jaswinder Ahujaji. He is Corporate Vice President and Managing Director, Cadence Design Systems, founding member and former President of VLSI Society of India. Honorable Chairman, AICT, Professor Sastra Buddhe, a very visionary and dynamic academic leader, eminent friends from academia, and dear participants, it is indeed my proud privilege to speak and address this august gathering on one of the most prominent and value addition schemes of AICTE, that is AICTE Training and Learning Academy. We very fondly call it ATAL. We have just now witnessed our Guru Purnima. So I am reminded of very powerful words of Swami Vivekananda. He alone teaches. He alone teaches who has something to give. For teaching is not talking. For teaching is not talking. Teaching is not even imparting doctrines. It is communicating. It is communicating with these powerful words simply translate into need for passionate, energized, motivated, and committed faculty members. And all of you would agree and acknowledge that with the progression of disruptive technological advancements and COVID pandemic, there is a paradigm shift in our teaching learning process. There is a total shift in the academic landscape. Our existing current education is cross-cultural, collaborative, cross-institutional, multi-directional, enabling convergence of man and machine, exploring new pedagogies, new academic landscapes. Our students are no longer mute spectators, but they are effective creators of knowledge. Teaching is no longer monologue. The system has become self-paced, self-directed, and interest-based learning ecosystem. Our techniques of teaching and learning have changed, where Skypes, wikis, blogs, video conferencing, animated laboratories, virtual classrooms, and personalized data from interconnected world have become some of the teaching tools. So often a question, very often a question, relevance of teachers in such changing paradigm shift of teaching learning. But in my very, very personal opinion, no technology can ever replace a teacher. But technology in the hands of a good teacher is truly, truly transformational. It is empowering. So with these towering changes, with these gigantic changes, what we need is continuous, comprehensive, relevant, project-based, hands-on training of our faculty members, and more so in emerging and thrust areas. And it is AICT is among so many innovations which AICT has been doing. It has been implementing NEP even before it came into existence. We are translating our technical content in various languages, various regional languages, and 11 we have already completed. We are truly, truly encouraging multidisciplinarity. We have allowed students to go for arts, liberal arts, and all other subjects along with highly technical subjects. So it is we at our commitment at AICTE that we are hand-holding and trying to take our teachers to the next level in these emerging areas. The anchor has covered already all the laurels which ATAL Academy has done. It has done a wonderful value addition in faculty development, and it has achieved unprecedented participation, unparalleled growth. Last year, more than 1.65 lakh faculty members were trained in online mode, and ATAL Academy has been awarded from World Book of Records, London. And this success is primarily attributed to all our partnering institutions, experts, coordinators, and amazing AICT team. And most importantly, my dear participants, it is your heartfelt participation because of which ATAL has reached where it has reached. So we have made a huge success, and I applaud each one of you, all of you. Now, what is our primary objective at ATAL? That our faculty development programs must ensure that our colleagues are motivated, engaged, fascinated to acquire new knowledge, associated skills, and visualize their applications in solving real-life problems. It is in this context, solving of real-life problems, that symbiotic and strong academia-industry linkage becomes imperative. And academic institutions' ability to help industry with innovations, inventions, and consultancy. And same way, the requirement of the industry to fall on various human capital developed by the academia is the core mission of contemporary global academia. So I feel the 5 P's: purpose, people, product, process, and profit. Financial profit in terms of industry, and intangible profits, that is development of human capital, are the 5 P's where we really need a meaningful academia industry relationship that would evolve around a strategy in pursuit of opportunities based on realization of interdependency to build synergy, appreciation of interest to maximize benefit, and assessment of concerns to minimize risks at both ends, academia as well as industry. It is also an indicator of the institutional quality that corporates are willing to fund research and academia is prepared for such knowledge transfer activity from academic innovations to the industry, or say patenting and a product development that will be useful, enhance the quality of life of our community, of our nation. There are too many benefits of academia industry linkage, but without getting into details, because I want our expert to speak about it. But anyway, closer collaborations is required between industry and higher education institutions to derive and drive passionate, good quality innovations and research. It is important that our esteemed colleagues participating, friends from academia, feel a deep sense of achievement post these faculty development programs. They have valuable take-homes impacting class transactions in emerging thrust areas, and apply this knowledge to solve real life problems. So dear colleagues, you are agents of change. I say in all my in all my addresses, pillars of quality education deliverance, responsible to transform lives into competent, cutting edge, humanitarian technocrats who encourage inclusivity, commemorate diversity, and celebrate absolute excellence. It is time to hear from industry leader Jaswinder Ahuja ji, former chairman of the Indian Semiconductor Associations. He serves on the governing body, Governing Council of Software Technology Parks of India, and is on board of Electropreneur Park, the first ESDM electronic system design and manufacturing incubators in India. Academically, he is BTech in electronics from IIT BHU, MS Computer Engineering from Northeastern University, Boston, and Executive MBA from Stanford. After we hear our Honorable Visionary Chairman Sahasrabudhe, we would just be very eager to listen from Ahuja ji. All the very best. Thank you so very much, my dear participants. Thank you.
Thank you so much. Now, I would like to extend my warm welcome to our guest of honor, Professor Anil D. Sahasrabudhe, currently Chairman of AICTE. In his 33 years of profession, from starting his career as scientific officer at
Dr. Shelley, please stop it. No, that's good enough. The time is short, so I would like to continue with a little about what we have been doing in different formats. At the outset, I would like to thank Dr. Jaswinder Ahuja, Cadence Design Systems Limited, who has kindly agreed to be the chief guest for today's program. A man who has excellent not only education but contributed immensely towards industry in terms of whether it is software development, STPIs, or in terms of other industry design systems. So I think we are very lucky to have him on such an important occasion. Dr. Mamta Agarwal has pointed out very beautifully about the role of teachers in such academy programs and how they can get empowered and then in turn take it to the students. Girdhari Lal Garg and my other colleagues from AICT who have joined this platform today, as well as 62 odd institutions from where today's workshops are being launched. These are all 5-day workshops on all emerging areas, ranging from AI, IoT, machine learning, deep learning, robotics, 3D printing, blockchain, cyber security. Do you call it, and anything which is going to happen in the future, next 10 to 20 years is part of all these programs. And this is what is invigorating. Because when we change the curriculum, we find that our teachers themselves who graduated 10, 20 years back never had an access to this kind of an education. And therefore, if they have to handle classes in these domains, they are found wanting. And then students sometimes will make fun of them because students are through internet, through various types of sources, would probably be one notch above the teachers. And that makes it much more difficult for our faculty members. And that's why putting them on the same level as that of what students probably are is going to be very vital and important. And in fact, they must be one step ahead. And that is why these faculty development programs are very intensive, 1 week long. These are almost like 3-credit courses. There are 14 modules. You can imagine 14 lectures from different eminent personalities coming and giving you those things. And then there are assignments. You are made to work hard. You are also required to give quizzes. So almost like student, you will be competing amongst your own colleagues from different colleges in India, different universities in India, and some of the industry experts giving you hands-on training, some of them giving you theory background. I think you will be holistic in those domains. And then if you are going to class, and there are whether it is MIT edX, whether it is Coursera, our own Swayam, I think you will be able to learn on your own further beyond what is taught in this 5 days. And with that, if you are going, I think you will certainly be doing a good job. Students will appreciate the kind of effort that you are putting in to bring them on par with the rest of the world. And that is why these academies, which we started 3 years ago, essentially earlier in the face-to-face mode with about 50 participants. Today, we have graduated to using online mechanism. And in the pandemic, there was no choice. So using this technology domain of using platforms, 200 people can join together. And we are able to train more than 100,000 people last year in about 948 workshops. This time, our bureau, Mamata Agarwal now and earlier Sony, had planned for 1,300 programs to train 2 lakh faculty members. I think this is amazing. Nowhere in the world such an initiative has been taken. And therefore, we are very proud that whatever AICT is doing to contribute, not only in terms of faculty development program, but in terms of new national education policy. We have already gone digital. There has been a paradigm shift in education, the way we handle our classes. Even after the pandemic, I'm sure some of the lessons learned are going to be used in terms of what we call today as blended learning, hybrid learning, or MOOCs. We will use every possible mechanism in order to make our students industry ready. And that's very, very vital and important because industry quite often talks about students are not employable. And some of the challenges that we had earlier was every institution does not have expertise in everything. And therefore, students were bogged down by learning whoever is available. And today, our gurus can be anywhere, from any part of the world. You can be from as far as east in Australia, New Zealand to Singapore and Japan, to also towards west, whether it is US or Canada. You have the whole world at your disposal. Faculty or the experts drawn from industry and academia from anywhere can be rolled in these 14 modules, and you will be trained in an excellent possible manner. So make use of synchronous, asynchronous mode, learn, and this learning will never stop. Right from birth to death, we are supposed to be learners. And something new comes up, we cannot say that I don't know this. You have to learn that. Maybe it will take a couple of days time, sometimes 1 month, doesn't matter. If there is a new technology which has emerged, we have not been taught in our curriculum in our university, should not say that, sir, we don't know this. I must be prepared for lifelong learning and learning by oneself. And today it has become so much easier compared to earlier during my time and that of Jaswinder Ahujaji's time. We had only one choice, that go to the library, search, hunt for the book. If it is not available, try to go to another institution's library. He must have done it in BHU. He must have done it in wherever he went. But today, late 90s onwards, the whole world is at your doorsteps. You can just at the click of the button, you have the entire information. But our students sometimes get carried away by reading something on the various pages of the internet. That is what it is. Sometimes it is not accurately presented. And therefore, conversion of that information, which is at their access, into wisdom. Knowledge and wisdom is important. And that is the role of the guru, the teachers. And therefore, we must have all of this together with technology. Teacher's role is becoming like a mentor, facilitator for learning. Learning should be according to what we said in our Vedas and Puranas and our ancient times, that we had Gurukula system. This is a new Gurukul. So in the new Gurukul, on one side there is a technology, there is an internet, but on the other side, a human being, human face is also equally important. And if we are able to do it, continuous development of both faculty and students will emerge. We have made internship mandatory. Some of our industry friends, like I would like to request Jaswinder Ahujaji, not only him from his company, but all their colleagues in industry bodies, be it FICCI, NASCOM, or the CII. We want internships. Our students should be aware of what all happens in industry when they are still getting educated. In their 4-year program, we have made 6 months internship as mandatory, but there are very few industries who are coming forward. We have 10 lakh students, 1 million students entering the system annually in engineering itself. Another 1 million join in other domains of architecture, pharmacy, management. So these 2 million children who come into the system, they need internship. And unless industry also comes forward and shake hands with us, it's not going to be possible. So my appeal through Ahujaji is to the rest of the industry as well, that you must come forward and provide internship, either 3 summer vacations or 1 full semester, as the case may be, depending on which university and college has what curricula. This is one very important thing. Just now, I got delayed by a couple of minutes because I was in Pune, College of Engineering, Pune, where the first Fab Lab in an educational institution was set up way back in 2009. And this was in association with MIT USA, one of very prominent professors of physics, actually not even engineering. He is a physics professor, Professor Gershenfeld, Neil Gershenfeld, who said 5th lab conference, Fab Lab conference to be held in Pune. And we had the encouragement coming actually for MIT from India. Please remember, there is a small place called Babel, Vigyan Ashram. And the Vigyan Ashram, Professor S.S. Kalbag developed this particular lab for school dropouts. How do we train them? How do we make them employable? And that was an inspiration for MIT to create Fab Labs. And the 5th Fab Lab conference was held exactly 12 years ago in 2009 in Pune. And that time another pandemic was on, not so much in large scale. That was called SARS, that came from Singapore, you must be remembering. And the delegates then also were wearing masks and using sanitizers. Was the first time that ever we saw. And during pandemic, we all got used to it. How do we take care of our health? But all the domains have got transformed in the last 12 years. And we have so much of enrichment of knowledge. How do we dedicate it to our faculty members and in turn to our students? Problem solving skills through our hackathons. Multiple entry, multiple exit, which our new education policy talks about. Academic bank of credits. How do we support research? All of this needs training and up-to-date information, up-to-date knowledge for our faculty members. And AICT's Training and Learning Academy is doing a small step in that direction. Of course, it has got world record, but our faculty members are 4-5 lakh. If you have trained 1 lakh is not enough. All 5 lakh faculty need to be trained. And that is the goal. Maybe in the next 2-3 years, we will achieve that goal. And my industry friends also will help. My academic institutions like IITs, NITs are also pitching in to help our AICT to conduct these programs. And let us make it happen. A new India is to be created, not just digital India, but also humanistic India, India which will show the world that we were once Vishwaguru and we will again become Vishwaguru. Thank you. Namaskar.
Thank you so much, sir, for enlightening us. Now, I would like to extend a warm welcome to the Chief Guest of Common Inaugural, Jaswinder S. Ahuja ji. Namaskar, sir. He did his BTech in Electronics Engineering from IIT Varanasi, MS in Computer Engineering from Northeastern University, Boston, and Executive MBA from Stanford University, USA. Jaswinder ji is the Corporate Vice President and Managing Director of Cadence Design Systems in India. He leads Cadence Global Customer Support and Educational Services Business and was the Chairman of
Welcome all to the first technical session of this FDP on deep learning and computer vision. But before that, I would like to invite Mr. Ashish Bajpayee, Assistant Professor, KIET Group of Institution, to aware the participants with the FDP rules. Ashish sir.
Good morning, everyone. I am Ashish Bajpayee, co-coordinator of FDP. I am tell you about some guidelines of FDP. So here it goes. As per AICTE norms, 80% attendance
Sir, I think there's some problem with the connection. We are not able to hear you. Ashish sir. Okay, I'm sorry, participants. It's just due to problem with the bad network. Okay, dear all, I would like to share some of the rules of this faculty development program. So during each session, we'll be sharing a link of the feedback form with which we will take your attendance, and 70% attendance is mandatory for the certificate. And at the end of all the session, we'll be having a test for the for qualifying the certificate.
sorry, ma'am, due to network
Yes,
issue.
sir. Yes, sir. Please take over the chance, sir.
Okay, thank you, ma'am. So an online test will be conducted at the end of faculty development program. The certificate will be issued to those participants who have minimum attendance of 80% and secured a minimum 60% marks in the online test. And after these, you need to fill the feedback form on ATAL FDP website. Then you can get your certificate. Next thing is, in each session, we will share our attendance and feedback form. I hope you got the clarity. Thank you, everyone. If you have any doubts, you can ask through the chat box and using MS Team query card. Thank you, everyone.
Thank you, Ashish sir. I want to clear a point that if you have some query, then you can raise your hand after the session and we'll be provide you the mic to ask the queries. So after that, now I would like to welcome Dr. Deepak Garg, Professor and Head of the Department, Computer Science and Engineering, Bennett University, for the technical session on the topic of Introduction to Machine Learning and Deep Learning. Dr. Deepak Garg is a committed academician with over 18 years of experience at leading academic institutions. He has an experience in automating and implementing the technology solution on a larger scale in the education sector. He also has an extensive experience in designing curriculum, developing education pedagogy, and managing industry institute interaction. Welcome, sir. Sir, over to you for the technical session.
Okay, thank you, Madhu, for the introduction. And thanks a lot, Dr. Ashish, for inviting me to this seminar. And thank you all other friends at KIET. So welcome to all the participants in this wonderful seminar. Thank you, Vineet ji, and others. Yeah, so let me share the screen. So let me know, is it visible?
Yes, sir. It is properly visible.
Yes, sir. Yes, sir. It is visible.
Yeah, my voice is okay.
Quite okay, sir. Quite.
Okay. So welcome to all the participants. So this is around 90-minute session on introduction to machine learning, deep learning, and we will see that how far we can go and introduce neural networks as well as hyperparameter tuning. So first of all, let us see, means many people, they are not able to differentiate between the three terms: artificial intelligence, machine learning, and deep learning. So as it has been shown in this particular diagram, you can see that artificial intelligence is the superset. There is a noise, I think. Can we ask people others to mute? Thank you. So we can see artificial intelligence is the superset of all technologies. Artificial intelligence is basically when we completely, partially, or in some delta manner, we try to mimic the natural intelligence of human being. So when we say that machine is displaying even an iota of intelligence which is similar to a human being, or doing some task which is trying to copy or trying to mimic the task that is being done by the humans, then we call that this is the artificial intelligence system. So the term artificial intelligence has also come from that. Otherwise, humans have natural intelligence and machines have artificial intelligence. So the intelligence of humans has not been built by some machine, but it is there in all the humans, and has been created by the superpower, by the Almighty. But natural artificial intelligence word is prevalent from maybe last 100 years. So initially in 1970s and before, we used to have decision support systems. We used to have some other heuristic systems and soft computing systems using some meta heuristic, which were initially called the starting point of artificial intelligence. But later on, after 1980s, there was another term that was being used, that is called machine learning. So machine learning has a specific definition. So machine learning means it when we say that the machine is learning itself. So what that means is, let us say a machine is performing at a level X right now, and after some time the machine starts to perform at level X plus delta X. So that means the machine, by running its operations, by further improving upon its data, it is improving itself. So that means machine is learning by itself, and its performance in terms of accuracy or in terms of efficiency or whatever operation the machine is doing as part of that machine learning system, it is improving in itself. So one of the good examples of that is that you all know that whenever you are working on a email client, so many emails come to your inbox and some emails go to your spam box. So this is a very ideal example of a machine learning system. So if we take the example of Gmail, the Gmail started around, let us say 15 years ago. So at that time also this concept of inbox and spam mail was there. But at that time, many of the good emails were also going to spam mails, and many of the spam emails were also coming to inbox. But then what the people used to do is that they used to mark some of the emails as spam and some emails as good emails which were going into spam. So by doing this, Slowly and slowly, system started learning in itself and started improving its algorithm and its parameters to determine which email is spam and which is inbox. So till now we see that even if the system has improved a lot, but still it is not 100% perfect. So still we can get rarely some email which is good as spam email and some email which is spam as good email. So this is an example of machine learning system. Then let us come to deep learning. Deep learning is a very recent phenomena. So it just started in this decade, last 10 years. So what happened in deep learning is that we are using the same concept of neural networks which is there many years before. But in deep learning, when the number of neural network layers, hidden layers, they increase from more than one, then we say that the network is deep, and people started using the term called deep learning. So if there is an input layer, there is a output layer, and there is a hidden layer, so that is a normal neural network. But if the number of hidden layers are more than one, then we call it as a deep learning network. And generally, ideally, the deep learning number of layers can be 10, 100,000 and more than that also. So because today, I think the major area of focus will be deep learning, because 95% of the application in the world which are now prevalent in artificial intelligence are basically following deep learning. So deep learning has three major categorization in terms of research. One is computer vision, second is speech and audio, and third is natural language processing. So by the name itself, it will be clear that when we are talking of the research area computer vision, it generally means that we are dealing with images and videos. And when we are talking of speech and audio, then we are basically dealing with audio files. And when we are talking of natural language processing, then we are basically talking about text input that we want to use in our application. But there can be some applications which are integrated, which have all the three components. For example, if you are talking about video analysis, if you are talking about a movie which you want to analyze, or YouTube video, so the YouTube video has some image also, it is a video in itself, it has some audio also in between, and there can be text written on various images. So it is a combination of all three. So a video is a very complex system to analyze, and combination of all the technologies or research areas of deep learning. So if we now come to the major problems that we encounter or we try to solve. So in computer vision, we are basically dealing with image classification and object detection. So image classification means that you want to classify the images, let us say, into dog or cat, or whether in front of a autonomous vehicle you have a pedestrian, or you have a traffic light, or you have another car. So like this, we want to classify the images. There are millions of such examples where we like to classify the images given to us. And the second major issue in computer vision is object detection. Object detection is that many times you don't only want to know that what kind of image it is, but you also want to know that where is the object of focus, where is the object of that we want to deal with. For example, if you try to find out that where is the pedestrian in this particular image, then you actually want to find the XY coordinates of that pedestrian so that you can accordingly deal with that particular application. So these are the two major issues. So a lot of research is going on, and every day, every month, we see improvements in the algorithm which can better classify the images and do the object detection. Then in audio, the major issue is voice recognition and language translation. So there are many applications of voice recognition. For example, if you want to open the gate of a security gate, or if you want to allow your employees to enter into a building based on their voice. So in that case, there will be a database of voice samples of all the employees. And when the employee wants to enter a particular lab or a particular building, he can just speak something and the system will recognize his or her voice and let that person enter into the building. So there can be many more such applications. And language translation, you may have seen that now there are tools available where if you speak in Hindi, then other person will actually listen in English. Or if you speak in Chinese, the other person can listen in uh, French. So like that means this is most advanced application of speech and audio area that people can do language translation. So a lot of work needs to be done in the local language in this case, because the companies start working on only on those language first, which are spoken by majority of the people in the world. But there are many other languages which still needs to be worked upon. So in YouTube video also you may have seen that many people now they automatically see the labeling of the videos. Nobody is writing those labels while the video is running, but it is automatically being generated by the machine. So that is also part of the speech and audio area of deep learning. Then the third is natural language processing. In these major areas are recommendation engine and sentiment analysis. So in recommendation engine, you may have seen now you are using daily basis Zomato, Swiggy or Flipkart, Amazon, or you are using many other websites for buying some products or for doing some activity. So that is example of natural language processing, because it processes various reviews given by the users. Similarly, sentiment analysis, while you are writing a review, whether it is a movie review, whether it is a review on Make My Trip, whether it is review on some other website, again you are doing the system is automatically doing sentiment analysis. So there can be many other applications. Then few other popular applications in artificial intelligence are written below. For example, a very important one in food security, that is known as precision agriculture. So in precision agriculture now, Israel is number one in that particular area. So precision agriculture is very much required for food security. The reason is that it helps to increase the yield of the crops and helps us to save the resources. So how AI system will work in a precision agriculture? So let us assume that you have a big field and there is a robot in that field. So that robot will be something like a tractor. So that tractor may have various boxes, it can have a box for fertilizer, it can have a box for pesticide, it can have another box for water, and then it will also be equipped with all the sensors. There can be humidity sensor, moisture sensor, temperature sensor, wind sensor, intensity sensor, color sensor. So all those different kind of sensors along with different cameras around the tractor will be there. So they will go in the field, they will keep on taking photos, and instantly they will keep on processing the sensory data that they are getting from the field. So based on the individual requirements of the plant, they will spray pesticide, or they will spray fertilizer, or they will spray water. So they will be giving very precisely what is required to individual plant. So that is how the precision agriculture works. So otherwise we just keep on throwing in the whole field, we throw pesticide, fertilizer in the whole field, but that is wastage of all these resources. So by this uh, robotics in agriculture using artificial intelligence, we are doing precision agriculture. So similarly, we understand learner profiling. So this is important in education sector, as all of you are involved in education. So based on the user characteristic, how much time the learner is looking at the video, where he is stopping the video, where he is repeating the video, whether he is active in front of the video or he is passive based on his facial expressions, how many questions he has solved, how much time he is taking to solve the questions, what is the speed of his typing. All these means hundreds of different parameters are collected by these online platforms, and they can profile the learners in a particular category, that whether this is a slow learner or it is a fast learner. So like that they can do the learner profiling. Then we have video captioning, that we have already discussed, that video can be captioned by artificial intelligence system. So satellite data is another a gold mine for doing artificial intelligence. Satellites are sending thousands and thousands of images every second, and it is terabytes of exabytes of data. So we need artificial intelligence to make use of those images. So recently you may have seen that almost every day new planets are being found. New phenomena in the space sector is being found. People are they have now generated the image of the black hole. So all this has contribution from the computer vision of image processing using neural networks and using deep learning. So then healthcare is the topmost area in artificial intelligence. So as you know that recently Microsoft and Google has developed systems where they can take the image of retina, and they can find out different kind of diseases that you have based on a single image. Similarly, people have also developed a system where they can take the image of your skin, and they can let you know if you have some diseases based on your skin analysis and classification. So people are working on oncology, people are working on diabetes, people are working in almost every disease, and they are trying to improve the processes and quicken the diagnosis of the diseases early in the period. So like that means technology is also working in the art and music area. So recently there was a music concert in Europe where the whole music was composed by artificial intelligence. There was now a recent auction in the Europe where the all paintings were created by artificial intelligence machine, no human intervention. And there was a fashion show also in Europe where the whole designing was done by artificial intelligence system. So you can means kind of imagine that where the technology is going. So it is going very fast. So these are the three main areas where deep learning is being prominently applied. So detection, prediction, and generation. So either we want to detect some pattern, or we want to predict the future patterns, or we want to generate some new thing. Either we want to generate music, or we want to generate a novel or a poem or a design. So we can work in detection, prediction of or generation. So this is the overall model for a artificial intelligence system. First we get the data, then we clean, prepare and manipulate the data, then we train the model, test data and improve. So this is a general model. You may have earlier also heard about it, and many times you also use similar model in software engineering. So we are not going to spend much time, so we can directly jump onto the technical part. Now many people ask me question that how we will decide that this problem needs artificial intelligence, or how we will know where to apply artificial intelligence. Are there some criteria that we can find out? So there are definitely criteria. So these are the 4 points where you can easily identify that whether this problem requires the implementation of AI or not. So number 1 is in all those problems where there is no deterministic algorithm. So that means if you don't have a deterministic algorithm available for that problem, then you can think of applying artificial intelligence for that problem. Let us again take an example to understand. Let us say handwriting recognition. So if you want to recognize the handwriting, for example, somebody has written how are you, and you want a algorithm to recognize that this is the word written how are you. So in that case, there is no algorithm available in the entire world, means nobody can write such an algorithm, because there are millions of varieties of handwriting. There is no particular size of the alphabets. There is no hard and fast uh, curvature and other features of the algorithm. So previously, before deep learning, if you have seen some research papers, those research papers were hardly giving the accuracy of 65% or maximum up to 70%. So whether it is image classification, whether it is speech recognition or handwriting recognition, without deep learning, people were just hovering around 65% or 70% accuracy. That is why artificial intelligence was not popular at that time, because nobody is interested in any system which is just 65% accurate. But now, because of deep learning, this accuracy rate has gone up to 90%, up to 95%. That is why people have started using such applications. The second point is problems which don't have a fixed solution and goalposts keep changing, and system is keep on learning from the experience. For example, we discussed about the spam emails. Another area is financial fraud. So is there any definition of financial fraud, that if this will happen then it is a financial fraud, if that will not happen then it is financial fraud? If we have a such hard definition of financial fraud, then every bank must have implemented this, and there may not have been any fraud after that. But what we know is that financial frauds are still happening, and people who are doing these frauds, they are also becoming clever day by day. So that means the definition of financial fraud is evolving day by day, and the goalpost is changing. So that is one parameter to understand, that we can apply deep learning in such cases also. And then we have where solutions are individual specific or time dependent. For example, recommendations or targeted advertisements. So let us say Amazon.com or Flipkart.com. So all these companies, they have around 10 million products or even more than that on their website. So do you think that anybody can handle this manually? Nobody can handle these manually. So that is why all these forums where solutions are individual specific or time dependent, they are again can use artificial intelligence. Then next is for prediction based on past and existing patterns, where it is not defined by huge number of weak rules. For example, prediction of share prices. So there are no hard and fast if then else rules where you can say that if this is the uh, thing, then this share price will go up or down. There is no such rule. Otherwise, everybody will become rich by now. So in such cases also, artificial intelligence can be used to define such systems. So then let us say why the deep learning has taken off now. So people are saying that what has happened now that deep learning has become so popular. So three things have happened. One is that more computing power is available due to coming of NVIDIA GPUs. So previously, when the people used to experiment on neural networks, it used to take days and months and years to do the experimentation. So people were not very much interested in doing this trial and error and hit and trial. So, but now what has happened is now we have NVIDIA graphic processing units or general purpose graphic processing units, which are 1,000 times or 10,000 times faster than previous systems, and the experimentation can be done very fast now. The second reason is availability of data. So previously when we were working on image processing, even getting 5 or 10 images was difficult. Now because of the explosion in mobile devices, sensory devices, IoT devices, so much of data is available easily. Now you can see thousands and thousands of data sets available free of cost online for different experimentation. Then next is release and development of new algorithms and new platforms for deep learning. So I remember previously means if I have to write a neural network application in C++ or C, I have to write maybe 10,000 lines of code. But now with a single line of code in Python, you can create a new neural network, you can define your parameters. So now it is very easy even for a non-computer science background person also to learn how to develop a neural network system. So let us see if you have some questions till now. So anybody having any questions till now, please write down your questions in that chat box so that we can answer. So after we answer some of your questions, then we can go ahead.
So the chat box is disabled for the participants. The participants can raise their hand, will provide them the mic.
Okay. So those participants who have any question, they can raise their hand, and then the organizers can unmute them and then they can ask the question. So in a faculty development program, I think asking question is of paramount importance, because if you have any doubts, any queries, it is important that some of them get resolved. So any of you who are doing PhD or who are already PhD and guiding some PhD, if they have any questions related to artificial intelligence, then please go ahead and you can ask any questions. Okay, we have one hand, Sheikh Shakil Abdullah. Okay, please go ahead and unmute yourself. You can ask the question.
Mr. Shakil, the mic is being provided to you. Kindly unmute yourself to ask your question.
Okay, probably he is not able to listen to us. Anybody else who wants to ask any question?
Sir, here is one question.
Yes, please.
Today there are modern tools. I have already used computer vision in 2009 also. Definitely that time accuracy was not more than 78% or 79%. But today technology has developed. Even people are writing one line code and they are getting everything. So very difficult to understand what is happening inside.
Yeah, you are right. You are correct that is actually now considered as the topmost challenge in artificial intelligence, that is known as explainability of AI. So because of that reason only, we are not able to implement artificial intelligence systems in critical areas. Because if we implement artificial intelligence in critical medical areas where the human life is also involved, and something goes wrong, because the accuracy may be 95%, so many people will like to appeal, or they will like to have some compensation for that because something has gone wrong. But as of now, because of the explainability missing, and the internal components of artificial intelligence are considered as a black box, so now many universities has opened up centers for research on explainability of AI. So explainability of AI is mostly consisting of three things. One is data, one is algorithm, and third is hyperparameters. So people have started doing research on this and trying to create a mathematical model for it so that they can find an answer to the explainability part. Okay, any other questions? So let us go ahead. So now we understand that why deep learning has taken off. So the essential tools that mostly we use is Git and GitHub, Python, Jupyter Notebook, NumPy we used for metrics and vector calculations, and Pandas for data handling, curation of data, manipulation of data. Matplotlib is being used for plotting of graphs for different analysis on data. And so many other Python APIs are there which are making it very easy to work on different neural network applications. So you also know that deep learning magic has some similarities with the natural intelligence. So when we say that our brain, if we go into the deep of our brain, then our brain also has something called axons and dendrites. And there are something called spiking factors. Then when something spikes, then it excites some other dendrites and so on. So without going into more details, because that will be more like a theoretical study. So now we have three types of learning algorithms in as part of artificial intelligence. One is supervised learning, one is unsupervised learning, and third is reinforcement learning. So 95% of the cases we are using supervised learning. So supervised learning means where we are learning from examples given by the user in form of labeled data. Means where we already tell the user that if some classification has to be found, then we already give many examples of that classification for training the machine. Then second is unsupervised, where we are learning the patterns in input data without any specific output values. So in unsupervised, we don't exactly tell the system that what it has to do. For example, if you give 1000 images to your system and you say that do some classification, then the system will do some unsupervised classification. It can convert those images into two categories, where it will say that these are images with bright light, these are images with low light, or it can say that these are images which have natural sceneries, these are images which have no natural scenery. So automatically it will come out with some clusters, maybe 2 clusters or 3 clusters or more clusters. So that is basically called unsupervised learning. Then we have reinforcement learning, which is the latest one people are now trying to do. So it learns by indication of correctness at the end of some reasoning. So generally it is made up of award, made up of the state of the system at that time. And depending upon how the system changes its state from X to Y, Y to Z and so on, and it keeps on getting some rewards. So that is how the reinforcement learning system works. So let us go into the details a little deeper. That first understand what we mean by features. So this is like ABC of deep learning. If you don't understand it properly, then you cannot understand deep learning. So we need to understand that whatever system we are working, it will have some features. So let us understand what are the features. So features are the elements of your input vector, means whatever input you are giving to your artificial intelligence model, the features will be the input to your machine. So here I have given you 7 examples of different system, that if you are trying to predict the housing prices, then what will be the features? If you are working on a spam detection system, what will be the feature? If you are working on a speech recognition system, or you are working on a cancer detection system, or cyber attack detection, or video recommendation system, or image classification. So these are most popular applications for using AI. In each case, I have given you some sample features which can be available or which can be used for that. For example, if we are using cancer detection, then if the doctor has given you MRI images or some other data related to the patient, then the clump thickness, uniformity of cell size, uniformity of cell shape, marginal adhesion, single epithelial cell size, number of bare nuclei, bland chromatin, and number of normal nuclei, mitosis. So these can be different features which can be given as a input in a two-dimensional array to your artificial intelligence neural network model. So I hope that by this example you now understand that what we mean by features of the application that you will be working on. The second most important thing to understand in this deep learning is what you mean by weights. So weights correspond to each feature. Means, for example, if let us say again the example of cancer detection, then clump thickness will have some weight. Weight means that how much it is important to detect cancer in the patient. So that means if it can have a weight of 0.2, it can have weight of 0.1 or 0.001 or 0.0235. So similarly, number of bare nuclei will have some weight, that how much important it is to detect cancer. Similarly, all such features in this cancer detection, every feature will have some weight, that how much this particular feature is overall important in detecting the cancer in the patient. So that is what we mean by weight. So weight is corresponding to each feature. Weight denote how much the feature matters in the model. So if you are trying to buy a house, I think the size of the area or size or area of the house will be the most important feature. So that will have the highest weight. or maybe the number of rooms in the house, that may have the second important feature. So like that, there can be different features while you are trying to buy a new house. So higher weight of a particular feature means that it is more important in deciding the outcome of the model. So if we want to go for a technical definition of weights, then slightly difficult definition, it is weights of a feature represent that how much evidence it gives in favor or against the current hypothesis in context of the existence or non-existence of the pattern you are trying to identify in the current input. So means the weight of the feature is the proof for getting the output of that system, that whether this, let us say, person has a cancer or not, or whether this house is costly or not. So like that. So generally weights are initialized randomly, means you don't need to guess the weights. Weights has to be randomly initialized. So that is the beauty and the magic of deep learning, that you don't need to do anything. It is not dependent upon your guesswork. So we are trying to bring the weights to near optimal values so that they are able to fit the model well. So that is a very simple overall objective of any AI model, that we are trying to optimize the weight values. So that is the whole story, that initially the weights are randomly initialized, and when your artificial intelligence model is trained, then you will have a ideal or optimized set of weights for each feature value. So to understand further, let us understand some more terms. There are two terms known as linear regression and logistic regression. So linear regression is for applications where output will be real value. For example, if you are predicting housing price, then what will be the output of your AI system? It will say the house price may be, let us say, 40 lakh rupees, or the house price may be 38.96 lakhs. Or if you are predicting the price of a share, it can say the output will be 32.49. So like that means wherever you have a real value output, that is known as linear regression. And if you have a output which is binary value, for example, true or false, right or wrong, yes or no, 0 or 1, then it is known as logistic regression. So linear regression is a very old concept. So for example, if you are given, let us say, n number of points in a two-dimensional plane. So let us say all these points, blue dots you are given. So you have to find the line of best fit in your given points, that which is the line which best fits all these points. So how we find the line of best fit? Okay, sorry, I got a courier. So how we find a line of best fit? So line of best fit is known by a term called mean square error. So mean square error means that we have to find a line where the distance of each point from the line is minimized. So that is known as the concept of linear regression. So we will mean this neural network that we are studying, this is just an extension of this concept in multi-dimensional world. Otherwise, we are doing the same thing, but we are only doing it in a multi-dimensional way. So what is the difference here will be that for two-dimensional thing, mean square error is a good loss function. So why we are using mid square error? Because squaring always gives a positive value, so the sum will not be zero anytime. So that is one benefit of using the squaring. And other is the squaring emphasizes larger differences. For example, if there is some point which is farther away from the line, then it will and when we square the distance, it will make it much more larger. So that means it will align itself with more points which are nearer to the line. So that squaring, emphasizing larger differences also mean that you can think of in terms of that it will have a effect on the outliers, that those points which are much farther away from the line. Another important point to understand deep learning is that there are two things known as linearity and non-linearity. So just keep one point in your mind, that in deep learning, linearity will never work. We are always looking for non-linearity. So why we are looking for non-linearity? Because we are not dealing with simple system. We are not really dealing with a system that whether this point is on this side of the line or that side of the line. We are dealing with very complex systems where we are trying to differentiate that whether this image is of a male or a female. So this male or a female finding in a image, it is not like just finding a point on a line. So it cannot be a linear system, means you cannot have a linear formula to define some pixel values, that if these pixel values are less than this, then it is a male, if it is more than that, this is a female. So like that, there is no simple system in deep learning. If you are trying to find out tumor or diabetics or cancer, it is not a linear system, it is a non-linear system. So all 100% of the systems that we are dealing with in artificial intelligence has to deal with non-linearity. So a linear function is just a polynomial of 1 degree, so that we can solve using simple linear algebra. But linear functions don't have much expressive power. That is why they are not useful for artificial intelligence. So that is why we will always use non-linear functions. So non-linear function, if we want to use, then we have to use activation function, because activation functions are helpful to bring non-linearity. So we will understand what we mean by these activation functions. So for example, even if we have to differentiate between this simple pattern that differentiate between yellow, red and blue, we cannot do it with a linear function. And our artificial intelligence functions are much more complex than this. Or let us say if we want to, if we are translating language, translating from one language to another language, that is 10,000 or 1 million times more complex than this particular simple function. For example, here finding a difference between a dog and cat. So many cat and dogs will look similar, their color can be similar, their size can be similar, their background can be similar. So it is not easy just to do a simple application, also a cat and dog application. So let us go to a deep neural network, that what it looks like, what are its various components, how it works. So this is a very simple diagram of a deep neural network, where you have the first layer known as input layer, you have last layer known as output layer, and in between you have hidden layers. So the rules of the game are that you will always have one input layer, you will always have one output layer, and you can have 0, 1, 2, 1000 or n number of hidden layers. Similarly, in the input layer itself, you can have 0 nodes, you can have 1 node, or you can have n number of nodes, where n can be millions or billions or trillions. Similarly, in the output layer, you can have one output node, you can have two output nodes, you can have n output nodes, where it can be thousands or millions. And in hidden layer also, you can have, in each hidden layer, you can have 0, 1, 2 or 1000 or 50,000 or 1 million nodes. And it is not necessary to have same number of nodes in hidden layers. Every hidden layer can have different number of nodes also. So you can see here that every layer is fully connected to next layer. Every next layer is fully connected to next layer, and so on. So if there are X number of nodes in a layer and there are Y number of nodes in next layer, then the total number of connections will be X into Y. So that means if we are trying to find out the total number of connections in the whole neural network, then you can understand and find out the relevant formula. Let us take a simple example of a neural network with one hidden neuron and one hidden layer. So just to make you understand that what is this whole concept, what is the story, what is the magic, how it works. So I am just taking here one input layer, one output layer, and one hidden layer. And in the hidden layer also there is only one hidden node. So if you can understand this, then you will be able to understand the complex neural network also. So this is a neural network where we are trying to find out the cost of a computer. So what that means is that, let us say somebody says that I want to buy a computer of a given screen size, of a given hard disk size, of a given processor speed, of a particular RAM size and a battery time. And you want to find out that how much this computer will cost me. So what we have done, we have already given 100 samples in an Excel file. So that Excel file is a 6 by 100 Excel file where there are 6 columns and 100 rows. So in all these 6 columns, in first column we have the screen size, second column hard disk size, third column processor speed, fourth column RAM size, fifth column battery time, and the last column is giving the cost of the computer. So like that we have 100 rows and we have that input file. So that means we have already given the system training data so that it can train itself that how the cost is calculated based on the available components. So now then you see this X1 is connected with Z1. And in this arrow you can see W1 is written, which is known as the weight of this connection. So that means how much this weight will be ultimately important. How much screen size will be important in determining the cost of the computer. How much hard disk size will be important in determining the cost of the computer. So accordingly we have given the formula Z1 is equal to X1 W1 plus X2 W2 plus X3 W3 plus X4 W4 plus X5 W5 plus B. So let us say if the weight 1 is 0.2, weight 2 is 0.3, weight 3 is 0.1. So like that, every attribute will be multiplied by the weight, and that will give you the value of the hidden node Z1. So this is a standard formula across all neural networks, across all hidden layers. So Z1 is equal to Xi Wi plus B, where B is known as the bias. So we will see why we are using the bias. So once you calculate this formula, then we apply an activation function on this. So you can see the second round in this hidden node Z of Z1. So I have just made them 2 rounds, otherwise it is the same round only. Just to make it clear, I have given 2 different circles. Otherwise it is part of the same process. So first we calculate Z1, then we apply activation function on this and we get non-linearity, and that is converted into the output. So what will happen now is this file that you have given to your system, it will give you some cost of the computer. But the cost of the computer is already known to you. It is given in the Excel file. So the system will compare that what cost it has calculated, and it will find out the deviation from the actual cost given by the formula on the top. Mean square error is equal to yi cap minus yi square. So this is how the calculations are done. So you have a input vector x1, x2, x3, x4, x5, and you have a weight vector w1, w2, w3, w4, and w5. So if you understand the mathematics of matrix multiplication, we cannot multiply 5 by 1 by 5 by 1. So that means we have to do something. So what we do is we convert W matrix into 1 into 5. So now we are multiplying 5 by 1 into 1 into 5. The multiplication is possible. But what is the problem is if we are multiplying 5 by 1 with 1 into 5, then the output matrix will come 5 into 5. So in every operation, we will actually keep on increasing the matrix size, which is not desirable, which will increase the computations. So what we do is we do it reverse. We multiply 1 by 5 with 5 by 1. So we take the weight matrix before and the input matrix after. So now the multiplication is 1 into 5 into 5 into 1, and the resulting matrix is 1 into 1. So that is how you get the value in your hidden node. If any questions are coming up, you can stop me in between. I can answer the questions so that nobody is stuck somewhere. If you don't get clarification on the previous slides, you may not be able to follow the next slide. So what is the activation function? Output from every neuron is generated after applying activation function to the values being calculated with set of inputs and their weights. So there are 4 popular activation function. One is called Relu, Sigmoid, Softmax and 10H. Relu is mostly used 95% of the time, and the Sigmoid is second most important. So then Softmax is also important. So Relu is called rectified linear unit. It is the simplest activation function. So the definition of and the characteristic of activation function is that activation function should be differentiable. And non-linear activation functions are there because it helps you to bring non-linearity in the system. And another function of activation functions is that they help you to transform the input value to output value in a desirable manner. For example, when you are using a sigmoid function, so your input value may be from, let us say, start from 1 and it can go up to 1 million. But the output value you are looking at, you are only expecting a output in terms of yes or no. So that does not help you. So in that case, the sigmoid function is very useful because it can transform any value, any real value to the domain 0 to 1. So in that case, if the value is transformed from 0 to 1 and your value is less than 0.5, then you can say it is a 0. If it is more than 0.5 up to 1, you can say it is 1, and you can automatically give the answer as yes or no or true and false. Then what is bias? Bias value allows the activation function to be shifted to the left or right. So if you see the diagram on the right side, there are 2 things happening. Means you have to find, like I said you in a regression function, that we are trying to find out the best fit curve. So this is again the example that in the whole artificial intelligence, our intention is to find the best fit curve. Now this best fit curve, there are only 2 transformations. Means either it can go up or down like in the first diagram, or it can shift left or right. So for shifting left or right the curve, only the function which is responsible is the bias function. And for otherwise giving a shape to the curve in a particular manner, the functions which are possible is the weight values. So that is the 2 important things in this, weight values and bias. Bias allows the activation function to be shifted to left and right. Bias only influences the output values. It does not interact with the input data. So that is why you have seen in the previous diagram also, the input to bias is always 1. By default, the input of bias is 1. So many people ask that when we are dealing with images, then what is the kind of input vector? So here I have taken an example of a 8 by 8 image, which is a colored image. So if it is a colored image, then it is a 3-channel image, which is having red, blue and green 3 channels. So in this case, it is 8 by 8 into 3. That is 192 pixels. So that means your input vector will be a array of 192. So if we are having a 10,000 images, then the total input vector will be 192 into 10,000. So there will be 192 rows and 10,000 columns, something like that. And this will be the shape of your input vector. So the first column is showing you the number of data points in single input, second column number of data points in second input, third column third input. So like that, if you have, let us say, m number of images, m number of training records, then you can understand that how your input data is positioned. So same case, you have the output shape also. So let us understand the sigmoid activation function. The sigmoid activation function is a standard function where it is sigmoid of z is equal to 1 divided by 1 plus epsilon of minus z. So if why this sigmoid function is useful, because I already told you that sigmoid function always lies between 0 and 1. So on the right side you can see the actual curve of the sigmoid function, that how it is positioned. So when the value is less than 0.5, it is taken as 0. When the value is more than 0.5, it is taken as 1. So here I have shown another example where we are taking a image as an input. In the previous diagram, in the example, we took as the text values of the computer cost as the input. Here we are taking the pixel values of the image as the input. So there is no difference in the working of the neural network. It is exactly the same. We have the same number of connections, and we have the same concept of input node, hidden nodes and output node. So everything will work in the same manner. So the difference between the logistic regression and the linear regression is that in case of logistic regression, the loss function is different. We don't use mean square error, but what we use is as a different loss function. So that loss function is written here, where it is minus of y log y cap plus 1 minus y log 1 minus y cap. So this is a very scientific and well proved function. So because it also in turn helps us then that when we want to go towards 1, then it also helps us accordingly, and when we want to go towards 0, it helps us accordingly. So without going into the details of this mathematical function, what I want to say is that it helps us to resolve the local minima problem and gives us a convex problem. So that is also a magic of this loss function, because otherwise if we have a concave problem, then there will be lot many issues with the local minima, local maxima. But when we have a convex problem, then there will not be any such issue, because if it is a convex problem, there will always be one local minima. So when we take a sigma, when we take a sum of all the training records of the loss function, that is known as the cost function. So otherwise cost function is same as the loss function, but only the difference you can see is that we are summing up all the training records. So we have just added the term called sigma is equal to 1 to m. Otherwise the loss function is same, which is y log y cap plus 1 minus y log 1 minus y cap. So then the another important function to understand is gradient descent. So here you are seeing a bowl like curve. So this is again a what we told you, that this is a convex curve. So every time when you are dealing with any deep learning problem, you will be having a bowl like curve, and your objective is to find the minimum value in this curve, because we want to find the optimum value of the weights. So let us say that in any random case, when you are giving your weight, assigning the weight value, so you will be starting at some point of the curve. So you can be either on the left side of the optimal value, or you can on the right side of the optimal value. So in any case, let us say if you are on the left side, then the derivative of jw upon dw, that is the derivative of the cost function that we have done on the previous slide, is less than the optimal value. That means we are supposed to add into the weight, because we are supposed to reach to the final value. So that means your weight is less than the desirable weight. And if you are on the right side of the curve, that means your derivative of cost of w by dw is more than the optimal value. That means you are supposed to reduce the weight, because you are again supposed to reach the final value. So this is the meaning of the gradient descent in a single dimension, but actually our system is multiple dimensional. So that multiple dimension gradient descent is not possible to be shown on a screen. So that is why we use this particular two-dimensional function to describe what is gradient descent. So this is a three-dimensional gradient descent function shown in terms of a bowl, but the clarification or the derivation is exactly same what we have seen on the previous slide. So now the question is how the weights will change in an actual neural network function. So in a neural network function, the formula is W is equal to W minus alpha dW. That first we start with the random weights. Then what happens to those random weights is after every iteration of the neural network and back propagation, the formula changes by alpha dW and the bias changes by alpha dB. So we will see that how it changes. So this is a detailed slide for that. So if you understand this particular slide, probably you understand 75% of deep learning. So let us say here you have two input values x1 and x2 given on the left side. So this is your input layer where you have two input values x1 and x2. x2 is 3, x1 is 5, and you have two weight values, and we have randomly started it with 0.5, and the bias is 1 as already it is. So there is one hidden node known as Z, and there is one output node where we are giving it as Y cap. So this is a simple neural network function with two inputs, one output, and one hidden node with one hidden layer. So we will try to make you understand that how the back propagation works and how the weight changes. If you can understand this, you can understand any complex neural network also. So you see Z is equal to W1 x1 plus W2 x2 plus B, which is a standard formula. So here we just fill up the values of W1 x1 and W2 x2 and B, and the value of Z comes out to be 5. And then we apply the sigmoid function on as the activation function, and the value of A comes as 0.99307. Now the actual value of this particular example given on the top in the blue square, original value of y is equal to 1. So when we calculate our loss formula, that is y I minus y cap, the output loss comes to be 0.0023, that is 1 minus 0.99307. So then as per our formula that we did in gradient descent, we apply the derivative of this, and we take derivative of loss function dl ay upon dA. So it comes to be, if you implement your derivatives here, which I am not going into detail, comes out to be minus y upon A. So you get some value. So then you go backwards and you apply chain derivation. You apply the chain derivation formula and you get dz. And then you go back and you find dw1. So this is how you change the weight values while going back. And similarly, you change the bias values. And again, you do the same calculations going forward, and again you go back doing derivations, again you go forward. So like this, forward backward you may do 1,000 times or million times. That is how you get the optimal value of your weights. So whether you are using a 1,000 hidden layer neural network or you are using million number of hidden nodes, this process will remain the same. So this is a much more complex representation of the neural network. So let us see what is Relu. So Relu is a simple activation function which the formula is max of 0, z. That means if the value of your input is let us say 1, then the output will be 1. If the value is minus 10, the output will be 0. So it will I take maximum of 0, z. So that is the value, that is the function Relu. Rectified linear unit is the default activation function being used. So some people have the problem that if you are using Relu, then if it gives 0, then it can create a problem. So what they do is they introduce a small slope to keep the update alive. So what they do is the formula is converted into leaky Relu, which is max of 0.1 z into z. So whatever is the negative value, even if it is, let us say, minus 1000, it will be converted into 0.1 into minus 1000 or 0.01 into minus 1000, so that it becomes a very small negative value.
Sorry to interrupt, sir. There is a query from a participant.
Yes.
Sir, in the previous slide, you said that A is equal to 0.99, right? So how did you get that value? Previous than this.
1 minute.
With a single perceptron neural network. Yeah, here. Here you said that A is equal to 0.99307. How did we get that value, sir?
Okay. So we have this as the loss function. Minus y log y cap plus 1 minus y log 1 minus 1 y cap, right? So
Yes.
here our actual value, which is given on the top, y is equal to 1 and y cap is 0.99307. So
Okay.
you can take these two values and put in that formula, you will get 0.0023.
Okay, okay, sir. Thank you, sir.
Any other question?
No, sir.
Okay, so similarly we have other activation functions, which is tanH and softmax function. So probably I will pass on these slides to you. We will not go into detail of these. So let me take you to hyperparameters, because that was also one important part of our delivery. So how we decide what are the various kinds of hyperparameters. So that means once you start training your model, in the first iteration, your model will never be perfect. You need to improve your model. You need to change your hyperparameters. You need to change your learning rate. You need to change other different kind of tuning methods. So how to improve the model? Once you have started it, how to further improve it? One point is that you may need more data. That means if you are using 100 records, you may need 10,000 records, or your data needs to have more diversity. So if you are using, let us say you are trying to find out whether this is a cat or dog, and all of your cat photos are white and all of your dog photos are black dogs, then it will automatically consider that whatever is black, it is dog, and whatever is white, it is cat. But that is not the reality. So that means your images has to be more diverse so that your system has a proper learning. And then your algorithm may need more training. For example, you may be working on your laptop, but you are not doing so many iterations on your forward and backward iteration that your system is not able to learn. So actually your algorithm may also need longer training. Or you may also need more hidden layers to be implemented, to be added into your system. Or you need to add some regularization. That means your system may be learning too much, or it may not be learning at all. So we will see what we mean by regularization. Or another method is we may need to change the neural network architecture itself. For example, you may be using some wrong activation function, or you may start using convolutional neural network or recurrent neural networks instead of artificial neural networks. So to understand the basic of that, first we need to understand how we distribute the data for improving the accuracy of the model. So any data set that you are using will be divided into 3 sets. The first set of your training data will be training set, which you will run when your learning algorithm is on. So for example, if you have 10,000 images, maybe 70% of it may be used for training data. And then you have a dev set which is used to use tune parameters, because once you have trained your system and then you are trying to tune it for better performance, you will need some more data so that you can compare it with the original performance. So you will use these dev set for tuning your parameters and make other decision regarding the learning algorithm. And the third is test set. Means now once you say, okay, now my efficiency is good and now I want to kind of roll it out to the final audience, that particular small portion of your data may be known as test set, which is used to evaluate the performance of the algorithm, but not to make any decision regarding what learning algorithm or parameter to use. So the traditional style partitioning is 70% training set and 30% dev set. But people now also use different kind of proportions. For example, if you are using 1,000,000 images, then this proportion can be even 99% as training set and 0.5% as dev set and 0.5% as test set. So it depends upon your data size. And it is also very important how you are choosing your dev set and test set, because the purpose of the dev set and test set is to direct your team toward the most important changes to make the machine learning system. So it is important that the dev set and test set reflect the exact data that you want to work in the future. So it is not like that you have trained your system on the cancer patients, let us say in Australia, and now you are trying to work it on the cancer patients in a small town in India. So that data may not work out because the whole type of parameters may be entirely different. Similarly, if you are working on a loan application and you are using a data from New York and you are trying to implement it in Ghaziabad or Faridabad, so that also may not work out. So similarly, bad distribution will severely restrict analysis to guess that why test data is not giving good results. So we have to properly distribute the data into the training set, dev set, and test set. So data distribution mismatch, it is naturally good to have the data in all the sets from the same distribution. So you cannot say कि भाई training set I will take from some different place and the dev set I will take from some different place. So that is not possible. Then for example, like I said, housing data coming from Mumbai and we are trying to find the house prices in Chandigarh. So sometimes we have only two partitioning of the data. In that case, they are called train and dev set or train and test set. Sometimes it is not possible to divide the data into three different sets. Then we can also work on doing the data into the two different sets. So another important thing is that we should always use a single evaluation metric to evaluate our performance. So some people, they use precision, some people use recall. So let us say if two groups are working on the same problem, if one person is using precision, another is working on recall, then they can get different kind of analysis on the performance of their data. Because the precision will actually tell you that how many examples recognized as true, how many of them are true in reality. And recall tells you that if you have got some true examples, there are total true examples, how many of them have been correctly extracted. So let us go into an example that what you mean by precision. For example, if you have 100 cancer patients and out of them you know already from your training data that 90 are cancer patients and 10 are not cancer patients out of the 100 records. Now your system recognizes out of 100 as 87 patients which are having cancer. So out of those 87, you have to see that how many out of those 85 fall from 90. So that is known as precision, that whatever you have found true, how many of them are actually true. And recall is from the total true example. Total true examples will be same as 90. So if you have found 83 as true out of 87, then you will actually find that from 90, that 90 are the total true examples and you have found only 83. So using a